Perfect. Good evening, everyone. Hello and welcome to yet another virtual FOF. We have quite a few participants, so I can see my clock is showing me 1 minute past 6:30. So I said people who joined early, they should get the benefit of starting on time. So today's topic, in my working title, I had labeled it as the API economy. But then I felt like I had also spoken on pharma before, and it might become clickbait, and people might accuse me of misleading them into watching a video on IT when they really wanted to watch a video on pharma. So I decided to relabel it in the final title as IT services and the API economy. So, as a coincidence, I think exactly uh, 4 years back, not exactly, a couple of days before, exact 4 years back, we spoke about the same topic. We spoke about the introduction of this topic called cloud computing technology and its impact on traditional IT businesses. And well, wish I was the same person then. I had a lot more hair, a few more pounds, but fortunately, I still retained the same shirt. So I just wore this shirt again for continuity. So people would feel that it's a good transition right into the same sector and continue the same discussion again. So what we saw in 2017 was very basics of what is cloud computing. We went through some of the definitions, some of the jargon that is used to describe what a cloud computing service is. We also went through some of the aspects in which cloud computing is used. For example, cloud computing is used as a private cloud where only one user gets to access it. It is managed by a cloud service provider. In a hybrid situation, there's a private as well as a public cloud, and there's a public cloud where data is kept on a shared data center where multiple tenants can reside on the same data center or even on the same server. So this technology has become quite mainstream since then. It was mainstream even at that time, but it has become even more prevalent since then. We also saw an interesting total addressable market of cloud businesses, and at that time it was around $40 billion, which included infrastructure as a service, platform as a service, and software as a service to some extent. So that total addressable market, which seemed like it was 40 billion, is actually Amazon's annual revenue now in AWS. So it's grown quite rapidly in 4 years. And of course, many companies are profitable, some are not, some are scaling right now. But it's interesting to see how rapidly this industry has grown. Of course, predictions were made that this growth will continue, and it has, fortunately, for the industry. And also, we saw a little bit about what the IT industry was doing. At that time, the narrative was very clear that people wanted to talk about digital and how they were going to use digital technology and these services like cloud, social media, analytics, and they were going to help transform clients' existing businesses. And to some extent, that thing has played out. And in many cases, where people were saying that the industry revenues were slowing down, many of the verticals were showing signs of maturity in terms of IT services spending. We suddenly seen a new upswing of revenue generation and IT spending in those areas because of these technologies. But when we look at the cloud in 2021, we are now living amongst hyperscalers, the giant cloud computing companies who have data centers all over the world. And they, in fact, are the dominant capacity in terms of data centers and servers available all over the world. So these hyperscalers include the top four, which is Amazon Web Services, Microsoft Azure, Google's Cloud Compute, even IBM to some extent. And there are other smaller players who also have dedicated cloud services providers to many of the other customers. So there were other companies as well at that time, but since many of these companies have alternate cash flow streams, they could scale significantly faster than the smaller players. We have also seen software is now moving slowly towards the SaaS way. SaaS is the software as a service, where previously we used to have softwares which we needed to install on our computers and then were able to use them. Now most applications run on the cloud directly, even though the front end might be sometimes on a device, like a mobile device, but most of these uh, softwares are actually run on the cloud. So we've seen that software as a service has now become a prevalent way of using software, and many of the companies who sell software as a service applications, they have actually scaled quite phenomenally. So enterprise software needs are quite always quite niche, and there's always some demand for some type of software, and there are several competitors if one category does very well to compete with the incumbent large player. But some of the larger software companies have in fact grown even larger on the back of this SaaS. So many companies have transferred their business models from selling packaged software on a CD-ROM or a DVD-ROM, or even download a software on your computer, to actually creating a subscription business model out of this. So, in fact, not even changing the revenue stream, but also the cash flow streams of many of these companies. But interestingly, the gross margins have stayed intact, and in some cases have even expanded because the costs get apportioned over a larger base of customers. Then, like I said earlier, the use of hybrid cloud has now become quite mainstream. Many companies, even small businesses, SMEs, do have a hybrid implementation of cloud, unbeknownst to them. So they might be using a server in their office, they might be using something on the cloud for a dedicated or specific use. So this actually has become a very prevalent use case for the cloud businesses. And in fact, many companies prefer that. In fact, regulations in fact encourage some of the data to be retained on premise and most of it to be retained anywhere you want based on the criticality of the data. And we have also seen another interesting trend coming in where most people were skeptical that the IT industry is in fact reaching its maturity and not being able to get large deals. Most of the large deals were taken up by the large IT services providers. We have in fact seen a crop of IT service players who actually won $1 billion deals, as if the $100 million threshold was too hard to beat. Many of these are long-term, multi-year contracts, sometimes even lasting for a decade or so, and these contracts are driving some of the incremental revenue growth for IT businesses. Of course, they are losing some of the older services that they were providing, but at the same time, these are transformational deals, and we'll talk about this later. What does that transformation mean? Because all these jargon is sometimes very hard to make sense of, but the numbers are staggering. The amount of deals that are cast by large players who want to quickly and rapidly change their enterprise from the legacy systems that they have to the modern technologies that are available right now. And lastly, for the star topic of today, we'll also talk about the API economy, which literally drives all software that we use nowadays, including the one we are using right now. So when we look at the story of IT industry's evolution, it's usually broadly chalked out into these categories. Like, there used to be a mainframe, which is a very different class of computer, which is used for transaction processing, and large amount of data can be processed in a very short amount of time. And they were like these chunky big boxes somewhere in the office. And in fact, you'll be surprised that many of the Fortune 500 companies still do rely on mainframes. Of course, modern mainframes, not the old ones which they were using. But mainframe as a computing class is still being used by many companies because they provide a reliable infrastructure for fast transaction processing on demand. But in fact, people were saying that, okay, this is a mainframe thing. The IT industry then migrated to becoming a PC client where the infrastructure was supposed to be managed by the IT outsourcing companies. And then suddenly we have seen that the business has gone to the cloud. So this is basically a very oversimplified way of how we have characterized IT industry. But the evolution is actually far more nuanced, and we'll see how deep the horizontals or the services that the IT industries have provided over the past 30 years. But before we begin, the staggering number, I'm amazed by the amount of money that is being spent on technology. Of course, we are depending on technology more and more these days. But the IT budget of a typical enterprise is somewhere on the lines of $4 trillion. And it is classified into majority these three categories. Hardware, which also includes networking and communication equipment. That will be a big chunk of this. Software products, which are including SaaS applications or even packaged software, which is sometimes used. They are also part of the IT budget. And another third of the business is essentially the services part, which includes consulting and even managed services for which IT service companies provide. And this budget is slated to grow at 3% on a CAGR basis. In fact, some categories within these categories are growing much faster. We know for a fact that SaaS softwares are growing much faster. We know for a fact that digital transformation deals are growing much faster. So within services, within software, there are fast moving categories as well. And this is not to say the consumer hardware that is being used. So consumer hardware is a totally different category altogether. This is basically the enterprise IT spend. So I still am amazed every time I see the number, which is a $4 trillion number, almost about 3% of the world GDP, pre-COVID GDP, I should say. But it's interesting to always see that the enterprise needs are not standalone. I mean, they are the very niche demand that enterprises have for spending on technology or software or whatever they need to operate their businesses is basically based on these four key characteristics. And I've stolen this shamelessly from Salesforce's presentation because I like the way they represented the enterprise IT need. So one thing that organizations need is essentially a record keeping system where they can have all the data in one place. Whatever data from transactions that they have gone through, whatever data that their customer interactions have generated, all this data needs to be kept in one place. And they need a system of record, a software that can record all these things. So we have database systems, we have a lot of backend systems which are capable of doing that. And they have been around for 40, 45 years now. We also need user interfaces which allow not just to engage with the software at the back office, but also now more importantly, we also need a front office engagement system. And these user interfaces are absolutely important. I mean, their importance, the designing of these user interfaces has become an industry in itself, and deservedly so. I'm not sure if you guys have read the recent article which came in the global media that Citibank had a transaction error which led to $500 million of money being debited without the bank's actual authorization, because the system that was designed to authorize, which had a maker checker system, was not the UI, the user interface was not designed very well, because of which the mistake happened, and even the maker and the checker made the same mistake, and they debited $500 million, which the court apparently said it's not the receiver's fault, it's the bank's fault. So we are waiting for the actual case to end, but it will be interesting to see if the liability is put onto the IT service provider who designed the user interface. Also, apart from user interfaces, the most important aspect of data is the business analytics that you can run on the data that you have. So a thinking system, or nowadays people talk about AI and ML. The AI and ML is only useful when you have a data which is stored in a specific manner, which can be retrieved afterwards and can be processed through this system. And then we can see that what insights this business analytics tools can generate. And lastly, the senior management do need a business dashboard, which gives them a visibility of what the entire business is doing at any given point in time. So all these softwares, so we have ERP softwares in the past which are capable of doing that. We have CRM softwares which are capable of doing record keeping. We have databases which can be manipulated afterwards with a different front end. So all these things are very broadly the things that IT enterprises need in order to fulfill their IT needs or technology needs. So now when we go back to 30-year journey, out of which I think the last 10 years is where I have been tracking the industry. But it's a fascinating journey when you go back and read the old annual reports, when you go back and read the old consulting reports cached on the internet. It's actually quite interesting to see how people used to perceive. And some of these things were so simply explained at that time. And in fact, there were a couple of reports which even explained the digitization, the cloud computing thing that will come up, although they thought it will come up in 2005, but actually it came in much later as a big technology. The roots were coming in 2005. Of course, the investments were happening at that time, but the prevalence of this technology is now very apparent, which some of the consultants had predicted in the 90s. So we, just to summarize, these are some of the phases which the IT services industry has gone through. And you can see clearly the 90s was the outsourcing boom when most of these IT companies from India were set up and scaled up. And these companies were taking advantage of a trend where engineers in India are cheaper to employ to do the IT work of companies and customers which are in more expensive jurisdictions or more expensive countries. So here the outsourcing slash offshoring continued. So we had a BPO boom, we had a boom of software developers who were also, so this is the time when the telecom equipment was being set up globally, the optic fibers were being laid. So the BPO boom actually came in much later, but the roots of the BPO boom started somewhere in the outsourcing phase in the mid to late 90s. So 90s was a very interesting time when most of the IT services businesses in India were actually doubling employee count almost every 18 months. So the Moore's law was in fact applied to employee numbers rather than the uh, chipsets. So outsourcing was a phenomenal time for cash flow generation, putting up your execution capabilities to display to the client, and you're able to show that you can execute large deals also. And some of these companies scaled very well. Then suddenly came a very interesting phase where all these trends got accelerated, where there was a Y2K thing, there was a dot-com boom, where programmers were required to churn websites and e-commerce platforms on the go as fast as possible. So some of these offshoring requirement also flowed in through dot-com bubble. And eventually, when the bubble burst, the outsourcing business was already there, but clearly some part of the froth went away, and the whole demand for IT, which people saw was could never go down, that suddenly people thought was not going to come. In fact, in the years to follow, we know very well that the IT demand, in fact, accelerated, but the valuations never caught up with what the expectations were at a dot-com time. So within this time, there's also another interesting business model which came up, not came up, but which became a larger part of the IT services revenues. This is the implementation or installation of package software. So you had all these package softwares coming from large software makers like Oracle or IBM, SAP, all these big players who were actually selling their software. They found that it is actually cheaper to go to market with an IT services vendor who will actually take care of all the installation, all the client concerns. So they will win the IT customer, they will win the managed services business, and we are going to get our license revenue without having to put in our people to help in the implementation and installation. So that saved a lot of cost for the software vendors. It was a win-win situation for IT companies and the packaged software manufacturers. So this went on for a long time. It still goes on to some extent, but now this packaged software no longer exists in the form that used to before. Now it exists in the form of cloud implementation. So even though the software has become changed its form from a physical package installation to a cloud deployment, you still need the help of an IT vendor in order to make sure that your entire system works together well and in a secure manner. Later on, another boom came in terms of infrastructure management, where we realized that now that we have better internet speeds coming from India, you could deploy a network engineer in India who can manage networks of thousands of machines anywhere in the world across the entire corporate network of a client. And those things happen because of software driven networks, and even uh, some of the softwares which were used to monitor these systems also became more sophisticated. So the whole remote infrastructure management phase passed the industry, and as the industry was entering into the last decade from 2010 to 2020, this kind of a decade where cloud was becoming more and more prevalent, we also saw the growth of engineering R&D services, where it started from doing very simple uh, low value work like creating technical manuals or making sure the OEMs or manufacturers who are outsourcing their engineering work to these companies are able to focus more on the core critical manufacturing and R&D work rather than doing the technical documentation work. But over there also, IT companies have excelled and they have evolved into becoming technical partners. They have hired consultants and become proficient in knowing what engineering needs do the companies have. And if there was a lack of engineers in a particular category, they would be the suppliers of choice for these engineers for a specific need. And lastly, we are facing the jargon of the day is digital, where in the past 6 to 7 years, most of the companies have moved to the digital investments. And its investments are mostly in people, adding the right kind of skill set in order to execute on these cloud computing projects, make sure that people are aware of what technologies are needed at the clients and what kind of combinations are possible. So you need more domain expertise as the domains itself. So for example, a finance domain, a pharma domain, a manufacturing domain will each have its own implementation needs and understanding, which these companies were acquiring as they started getting into the digital phase of IT industry. But what we see here are not just phases in the industry, and this is actually a very interesting differentiating factor, which is not very obvious from the outside. But most of the IT companies claim that they are full stack. What they mean is that they can provide all of these services on demand whenever they require. So they can provide implementation, they can provide outsourcing, they can provide basic managed services like infrastructure management, ER&D, as well as digital execution. But most companies want to talk about digital. It's like a tip of the iceberg. A small part of the contract will be a digital contract, and the rest of it will be the traditional IT managed services, which we are seeing here. So what happened here is most of these companies became more niche and niche. So we have a large list of small and mid cap size IT companies who are extremely niche players and providing niche services to customers and doing very well indeed. But there are some larger companies who are the large cap IT companies. They in fact are full stack, and they have the manpower, they have the investment muscle, they have the management bandwidth now to actually execute across the entire stack, whatever the demand may be. And it's no wonder that some of these larger companies are winning the $1 billion kind of deals because of their past proven execution capability. That's something not very easily visible. I mean, you can always see the numbers, and when we look at the broad growth numbers, we are always disappointed. The industry can grow faster, but why this company XYZ grows slower? But actually, internally, they are changing a lot to adapt to the new technologies. So, what I would say is not the phases of IT industry over the past 30 years is essentially a capability building over the past 3 decades, right from the founding of many of these companies to the digital world that they're living in now. So coming to the jargon, so what is digital? A lot of people throw it in conference calls. CEOs, they love to animate some of the examples, but actually sometimes becomes very difficult to pinpoint what exactly they are doing. So, and it's natural if you are not in the technology industry or you have not seen a particular digitization contract happening in the organization that you work for, you will not be able to appreciate the detail or the kind of painstaking change that is needed in an organization to do this digital transformation. So the first thing that IT services do when they take over a digital contract is to analyze the infrastructure and the apps that the organization or the client is actually using. And once they have a good idea of where are the gaps in terms of investments that the client has, and which softwares can they upgrade, which softwares they should upgrade, because a lot of these softwares also would have been dropped by their software makers in terms of providing updates beyond a certain version. And due to lack of investment capital available, most people would not want to buy. But nowadays, when we see softwares are available as a subscription model, your outgo is not very high. You can pay as much as you use per seat of usage that you do. So per user fees you can pay on a monthly basis. So you can actually distribute this instead of a capex kind of an investment. You can make this as an operating expense and expense it solely over a period of time, and the software keeps on upgrading itself in the back end if the software provider chooses to do so. So this analysis happens. This is a consultative phase where most of the consulting contracts by even third party consultants also result into giving up solutions as to what you should do as a customer. And then the customer chooses based on the budget that they have, based on the requirements at that time, based on their scaling capacity and everything. They will choose the right software. But once this choice has been made, in fact, the next step, which is far more important, is that you need to choose the data that has to be migrated to the cloud in order to save incremental investments in servers and hardware at your end, or some of the data has to stay with you because it's maybe competitively more important for you because the regulators don't allow it. A lot of reasons where data has to be retained in your own cloud, in your own server. So some of this data is migrated based on priority, based on how the data wants to be accessed, where in the world the employees are going to need it. So all sorts of permutations and combinations are figured out, and then the actual migration starts. And this is where most of the IT services players do work with the hyperscalers or the hyperscale cloud providers in order to take advantage of their infrastructure and at the same time build that long-term relationship. Sometimes the contracts can also come through the hyperscalers when they approach a customer and the customer says, "Hey, do you know any competent IT services player?" So they raise a request for proposal and they invite all the companies to bid, and then they bid, and the best bid wins over a period of time. So essentially, these are go-to-market deals. These are also originated by the existing IT services players. So, for example, if you are servicing a client for the past 30 years, being in the industry for a long time, the client would naturally come to you and get your feedback as to what you think based on the systems that you've managed for 30 years. What do you think you should be doing? And the migration then happens to the cloud in some way or the other. So here we have seen that the hybrid cloud has been the most preferred option in many cases, where clients do want to retain some of the independence of how the cloud is managed, because they have also invested in their employees and their internal IT staff who is capable of handling this hardware. But clearly, the new demands of scaling suddenly, or a spurt in the use of computing requirements that you might have, those can be handled far easily on the cloud. And lastly, which is the most interesting part of the digital transformation process, where you have already analyzed everything, you have now migrated and you have basically designed the entire infrastructure, how it is going to look in the future. Now you have to clearly say what you need to do in the business to modernize your technology usage. So, for example, if you were using some old legacy softwares, some of them need to be rewritten. If they have a customized software written for you, rewriting can be putting them on the cloud, making them a cloud interface kind of a thing, where it becomes model, it can be accessed from anywhere, and also be monitored from anywhere, and also managed from anywhere. If at all something goes down, somebody else can pick up and see what's working, what's not working. There is no need to be in the customer premise to do it. Also, some of the, like I said, some software need to be replaced. So if a competent software is available, which is a cloud software or a SaaS kind of a software available, uh, then the IT vendor can also recommend to switch to that and switch all the data from the previous system to the next system without data loss, making sure it works and does not interrupt the business. So all these things are quite painstaking. You can imagine it's like changing the engine of a jet plane while the plane is flying. And these are very, very critical systems for many businesses. And these are necessarily, because of this criticality, they are long drawn projects. They don't just start and end tomorrow. So there are small parts of these projects which can be short duration projects, where you need to implement something very specific, like you need to create a feature or update something, or do something, a small part of the implementation. But if you look at the overall process of digital transformation, uh, as long as those that phrase is, it actually is a long drawn contract from analyze to modernize. But today's presentation will definitely want to focus more on the modernized part, because that's what is really driving some of the new age demand in IT services. So imagine this is a badly drawn smartphone, and the black dot at the bottom is the app, one of the many apps that the phone has. And the things that the app can do, I mean, nowadays modern apps are so sophisticated, they're designed so well. In fact, they are supposed to be designed well, otherwise they will not get entry into the app store. In many times the restrictions of making bad apps has actually gone way up, and both Google Play Store and the Android store, or even people's taste in software, how it should look like, all these things have actually improved quite dramatically, because we have seen a wave of user interface design coming in software development as well. So imagine this is an app on your phone, and look at the kind of services the app provides, or the things that the app does in the background. So one thing is that the app will authenticate you, because you are the rightful user of this particular app. You're logged into the app. If the app has a transaction system into it, it can allow you to transact. It can provide a billing system to you after transaction is done, to tell you that okay, this is a bill generated for you. I can also create a payment interface for you, where it connects to a payment system in the back end. It links your bank to the payment interface and a payment gateway. You can also keep a record of all your orders. You will be able to see whatever you have transacted in the past. You can also track your order if it's in the middle of delivery or something like that. You can track your order on the same app. In fact, if you want to reach out to the customer care of the app provider, you have an option to do so. It can be a telecall, it can be a chat bot, it can be several things. And if the app does support advertisements within the app, then there is also a way to show you the ads. So the capability of these apps, a small tile on your phone, can actually have tremendous capability. And this capability is basically what the modernization of software means. Previously, all these things were also available, but for that, you had to install a far more sophisticated software on each computer. And even the websites needed to be very sophisticated with all these things connecting to them. And it required a lot of effort. But now this effort has become easier, and we'll see how. So one thing that has changed since the software industry in the past and software industry today is that now there is a system, a supply chain system available for the software industry. Let me explain to you what it means. So when we hear the word supply chain, it creates these kind of images. So when I hear the word, or when I read the word supply chain, I immediately, my mind goes to something like a factory, and something is coming on a conveyor belt, and robots are working on it, and something gets assembled, it is shipped and it goes as a finished good to somebody else. So in my mind is that I have the manufacturing mindset in terms of looking at what a supply chain means. And I think most people who are probably older than me also will have similar kind of a physical infrastructure in their mind. So it's a little difficult to really imagine what a software supply chain can look like. So in fact, if you take an example of the auto industry, the auto supply chain is a classic example where you can see all the parts laid out, and each and every part is made by a specialist. So you will rarely see an auto company saying that we make our own car tires, or you will rarely see somebody, oh, we make our own transmission, or you will rarely see somebody that, okay, we have supplied our own brake pads. You actually, every single component of a modern automobile is actually made by an auto ancillary, and the auto ancillary is a specialist in that particular ancillary that they're making, and that part is supplied to the auto company through the just-in-time inventory management system. So we know the management jargon, but it actually is a very intricate and very well balanced supply chain which has been working for the past several decades. And for any matured industry, we will always feel that, okay, it's obvious that there will be a supply chain, because the auto company would not want to keep on investing in upgrading all these things, right? I mean, the auto company was doing all these components. They wouldn't be making good automobiles. They will be making, perhaps they will be making badly designed cars, unless you're a Ferrari. They make everything on their own. So interestingly, most of the mass market auto companies do rely on very specialized parts providers, and that is a sign of a very matured industry. That the industry has now accepted that there are assemblers and there are manufacturers of specific parts, and the assembler and marketer will actually make the cars. So API, which is the definition of the full form of API, the word is the application programming interface. And these are the components of the supply chain in the software industry. Now, these components actually help you connect to the thing that we saw on the app earlier, that each and every component, each and every service that the app is doing is provided by this application programming interface. Now, who makes this application programming interface? Well, like the auto supply chain or any other matured supply chain, there are very specialized vendors who provide very specific services in the software supply chain. And these specific services or products, which are called the API, they actually provide the backend system which makes sure that the app works the way it works. And there are some good examples I will discuss in the future also. But before that, I would like to talk about this fantastic book I was reading. It may not be the motivation for this presentation, but actually, I thought that there's not too many books that talk about what is happening in the mind of a developer or a company that creates APIs for a living, and how this API is used, and why is this API economy now booming. So the gentleman on the left, his name is Jeff Lawson. He's the co-founder and CEO of a company called Twilio. Twilio actually sells APIs for contact center operations. So if you have a SMS or a call-based system which you want to implement inside your app, you will most likely use one of the Twilio's APIs or any of the competitors' APIs. But Twilio is a company who does provide contact center APIs. So this book called Ask Your Developer actually is a very personal journey that the author takes us through about how he chanced upon the API ecosystem and what has been his experience in running a business that generates 75% of the revenue by selling APIs. So API has become the new product for many of these companies. So previously, people used to sell a fully finished product, which is the software which the end user will be using. Now people are selling components which go inside any software which requires that component. So imagine like a tire manufacturer can sell a tire to a bike, can sell a tire for an automobile, can sell a tire for a off-highway vehicle. So you're basically providing very specific components which fit into the requirements of the customer to whatever software needs that they might have. So I would urge you to read. It's a very small book, written in a very simple language, provides a lot of examples, and gives you not only the importance of what the API economy is becoming now, the history of the API economy, but also if you are inclined, is what it takes to hire, retain, recruit developers who have this kind of a mindset to create these products, to make sure good software teams how they are run. So it's actually a very nice book. One of the rarest books I found. On IT industry, there's not too many books available to read because most of it is B2B and extremely generic very specific examples. You cannot generalize a lot of these things. And also, clients will frown upon being discussed in any capacity by any of the vendors. So, interacting with IT industry people, you get a lot of good stories about how technology has evolved. But without the access to those people. This is a very good book to see what is happening in the API economy. I would encourage you guys to read it. So coming back to our app, the Octopus-like app was doing all sorts of things like authenticating, order tracking, record keeping, customer care, transactions, billing, everything. So all these things are enabled by very specific APIs, which make sure that the app does the exact same thing. So if you click on login, it will invoke the or will call the API which authenticates you. Once the authentication is completed, the API goes back to its place, which goes silent, and the app goes to the next step where whatever the app is designed to do, it will do based on what API is called afterwards. So the software creator of this particular API, of this particular app, has only one decision to make, is to make sure that their app is used by as many users as possible, and their app is relevant. There's a business model behind it, which is allowing them to use all these APIs. So let me give an example of the virtuous cycle of how the API economy works. This is an app most of us have used. So Uber is a day-to-day app. I think probably people use it once or twice a week, at least nowadays. But if you look at Uber, there's a lot of things that Uber uses to make Uber run the way it runs. So, for example, hosting. If you look at the first thing on the left, so hosting is essentially Uber is not hosted on some server in some in some Uber headquarters somewhere. It's actually hosted on the cloud using public cloud technology services from AWS or any other computing cloud provider. And the way it works is it works seamlessly. You never feel Uber is down ever. It's like Netflix also is never down. It works on the cloud, but it's never down. It is the uptimes are ridiculous. So when we see a technology working so seamlessly, we know the reliability of these cloud systems. So they pay to host services on the cloud. Also, they must be paying for other APIs. Like we saw the tentacles coming out of the app. It also has authentication, payment system. It has all these APIs that they are using. One of the most important features, which is the most visible feature and gets a lot of real estate on the Uber app, is the map. So whenever we book a cab, we have to see where the driver is. The driver has to see where we are. Then once the ride is started, you can also track where you are in the journey. So you can use that app at the same time. And you can also see the driver who has access to the app, and you can, if the driver is mounted to the phone, we get to see where we are in that display. So Uber has to pay for maps. In this case, it is Google Maps. Uber also has to spend money on marketing. They might want other people to notice that Uber exists, so they will advertise themselves. In fact, you must have seen that when you go to Maps, Google Maps, you put your destination in and put directions. You get an option to hail a cab directly from Google Maps. It's also a marketing feature where Uber and other competing cab providers will also be present over there. Also, there is a payment option where you can pay for the ride. In India, you can use UPI, and the payment option is something again is an API which is provided to Uber by a service provider, and they pay for that API. So in many cases, like for example, now there is a Amazon cashback going on if you are using Amazon Pay to pay for your Uber ride. So that means Amazon is paying something back to Uber in order to come up as a preferred choice for many of its riders or users of Uber. So you can clearly see a virtuous cycle going on over here. And when you see an app like Uber work with the APIs that they have so seamlessly, and it always works. I mean, I've never had an experience where Uber app crashed or it did not work. No matter what phone I was using, even I've seen older Android phones which cannot upgrade to the latest operating system still use an older version of Uber, which just works. May not have all the features in terms of payment options, but it has all the basic features you need for the app to function. And when other customers see that Uber, which is a critical app and a business model that runs on single transactions, billions of transactions in a day, uh, they must be clearly impressed. And then these are used as use cases and case studies to sell these APIs and cloud services to other customers. So it's a very interesting virtuous cycle where observing one thing doing very well can lead to other things. And clearly, there is a startup ecosystem where there was a time when everybody wanted to create a Uber of something, right? So, for example, if you wanted to create a food delivery service, which uses the same interface that Uber has, then of course Uber also has its own food delivery service. But if there is a competing service they want to create, they will also need to use an authentication, a payment system, a tracking system, order monitoring system, all these basic functionality that Uber also uses. The same API can be used, and based on your interface, you can create your own app. The underlying components might be the same. It's like imagine a car where there's a Mercedes and a BMW. Of course, the engines are very unique, but it's a car, right? I mean, you're still sitting in a car. It's providing the same function to you, but components are different. Components are similar. I mean, you can have the same Pirelli tires, you can have the same transmission system, you can have the same shock absorption system, you can even have the same seat vendor who's creating the fabric on the seat or the leather on the seat. But actually, it's two different situations. So Swiggy and Uber might be two examples you can see where they are using probably the same underlying technology, but at the same time providing totally different functions in what the app is providing. And in fact, if you are curious to know which technologies are used by a specific app, in every app you can see there's a legal section or a terms and conditions or a privacy policy. If you just go through it, it's a boring documents. Don't try and make sense of them. But sometimes they're very interesting. So especially if it's a WhatsApp privacy policy. But if you go through the documents and if you see what's going on, that which kind of services they rely on, and how your data is being used by different services, what sort of handoff the data goes through. It's quite interesting to see what sort of technologies are used, what sort of open APIs are used. Open APIs are something which are managed by an open source community. There is no single owner, but a community of API enthusiasts basically maintain that API, and code just runs every time. It's updated by a community. There are some private providers, which essentially their business model is to create the API and to maintain it and make sure it runs all the time. And incidentally, those API providers also rely on cloud computing services to host their APIs. So the use of cloud is actually quite pervasive in all these things. The app runs on the cloud, the API runs on the cloud, everything runs on the cloud. It's quite interesting to see how everything is so interconnected in this virtuous cycle. And the dollars, obviously, just to show where the money flows. Sometimes you will get to see, this is a slightly oversimplified example, but just trying to create a picture in your mind that every app you use has a deep layer of technology and components working behind it in order to make it function the way it does. And when something breaks, I mean, we have seen examples of a large bank in India whose app failed apparently when they upgraded the app. The systems were running, but the app apparently failed. So it's actually quite possible, even in these days, this time when we have such sophisticated technology available, if one of the components in the backend fails or if something doesn't work the way it's supposed to work at that time, you really can see a failure of app of even a large company. You don't know. So just to give you an idea of how these APIs are priced. So I'm just giving you an example of Google Maps because it's more visible and easy to remember. But if you see API providers, they will have a rate card on their website, or they will provide technical documentation to the developers who are going to implement it, and they will give a rate based on the usage. So there will be some free kind of a usage where if you're using it only for a few number of times, then it will be free. But if the usage scales as the app improves, then you can actually get a better deal in terms of using the app on a volume discount. So imagine if you are a startup trying to fund yourself, you will have all these kind of costs in your mind when you're trying to use different components to create your app. So in fact, all these components also allow you to build these things on your own. I will look at it later why it is an interesting thing for the API economy when all these components can be put together so easily. And you can fund a startup, you can create the software, you can start marketing your app, and you can actually get going immediately on day one or even day five of creating that team and starting to run your business through an app. So Google Maps, again, this is the maps system where you can just get the static maps to see where you are and pinpoint your location. You can also get routes where you can see from here to here how much time will it take. It will have traffic information. It will have other alternate routes provided to you. And all these things are essentially a software call. The software basically just calls that particular function at the right time and it shows you the information instantaneously. And because we are now always connected to some data plan or the other, these sort of things become more and more prevalent. We start to think this is automatic and this is how things are supposed to be. So imagine a lot of the backend telecom infrastructure that has been put in and the kind of rates that we pay for data plans when you're out and about. It's actually quite amazing. Without that, these things wouldn't have been so prevalent. You wouldn't be saying that this is how it is supposed to be because it wouldn't be available to us all the time. We would be very scared to use Google Maps because the data costs were too high. Because if you look at the data usage nowadays, I don't think anybody tracks it. But previously, if you tracked the data usage when the Google Maps was turned on, it actually used to consume a lot of data just to show you the rich satellite pictures of the map where you are and the route that you're taking in. So again, there's a rate card for all of these things, and you can actually build a PNL of all your items if you're a software designer, to know which components will cost how much. It's exactly like how a matured supply chain works, right? I mean, you know exactly how much an auto company will know exactly how much a tire will cost, how much a shock absorber will cost, how much the sheet metal will cost, everything. They will know everything to the minutest detail. They will know the timelines for delivery of all these things. In this case, it is instantaneous. In many ways, the software business, selling software, is actually, I don't know, it seems criminal, but it actually is such a wonderful business. You create something once, you maintain it to the operating capacity, and you can sell it infinite number of times based on the use case that you can create. It's marvelous the way softwares can be sold. We have so many great examples. You have Microsoft, Oracle, some of these software companies where the entire code base was written once, and we have just seen incremental additions to that, and there's no complete transformation in the software that we are using. But this is an interesting business. Right from the 1970s, these companies have been selling software profitably. So wanted to highlight this. So when I mentioned earlier, there is a then and now in terms of how software was created, how software was used. So in the past, if you wanted to be a software developer, you need to have first of all really big guts to start, because you have to raise capital, you have to hire people who are going to go with you with the idea that you want to build a software. Then you have to basically build all these components. You behave like a Ferrari. You have to painstakingly build every single item that goes into the software. Then you need to also consider the hardware on which the software is going to run. You test on all the hardware properly. By the time, imagine the amount of money that has gone in just by looking at this activity, doing this activity right now. And then you have to find a way to implement it. Then probably you go to an IT vendor, teach them how to implement it, and then they will implement it on some customer. Then you do a revenue share and whatnot. And then there will be a time when, after a few years, there's a time to upgrade the system because the technology has moved on. You need to innovate the software, otherwise the competition who has a newer software will displace you. So this was the way software has been developed for the longest period of time. But now when you look at the API and ease of using these components, you have bunch of developers can be hired. They can connect the components and see how they work. And like I said, there are some plans with APIs where you can do testing very cheaply. You don't need to spend a lot of money just to test. But if you're using it at scale, you will have to pay a lot of money or negotiate with the API provider to make it cheaper for you over a period of time. So you can basically connect these components and see how these components work. You can have a working app. So nowadays, what they call as hackathons. A bunch of developers sit and basically say that this is a problem I want to solve with software, and let's see if I can create an app which uses available APIs right now, and can this app do something in the real world which is a need in the real world. That's how many businesses start actually. Uber, if you imagine the origins of a company like Uber, who thought that this was no longer accepted? I mean, we stand in the middle of the road and raise our hand, and some vehicle stops. It can be a rickshaw or a taxi. Who thought that this required to be digitized? But actually, the moment you start using it, you get it. You just instantly get it how intuitive it is and how useful it is to not having to stand in the middle of the road and wave your hand at a taxi. But this is a digital way of doing the same thing. So they will see how the components are connected, and they will iterate. So once they realize the components work well together, let's see, let's do A/B testing. Some set of users will get a different version, this set of users will get a different version, and then they will compare which has more intuitive way of navigating through the app, and then they will choose the best version every time. So imagine this iteration happening constantly, and basically, the API ecosystem or the API economy allows you to run these very, very cheap experiments on all these components. So you have a working system immediately. You don't need to spend a lot of capital, time, and effort to create a software system anymore. It's a massive improvement in the way software is designed nowadays. So in January last year, I spoke about the platform economy, and the reason I don't want to touch upon this topic here is because it is a very relevant topic, which covers the background of how platform economics work. So I would urge people who want to understand the economics of this industry to go and look at this video. You'll probably get a sense of how different variety of businesses can be created out of the platform economy. So APIs again are platforms. I can also say a platform which connects two components in the system, where people can build something on top of that. Where people can create an application on top of these components in order to make sure that the app does what they want to do. In fact, what I've seen is it is not a phenomena only in private enterprise. In fact, governments all over the world have been digitizing at a rapid pace. And thanks to cloud computing and the cheap way of storing data available to them, I don't know how many of you are aware, but this I found to be a fantastic thing. So an app called DigiLocker. If you haven't used it or haven't heard of it, I would urge you to download it just to see what it does. It's a phenomenal app, and DigiLocker provides this system called API Setu. Again, these names are also quite amazing. So API Setu is for creating this digital transformation system for the government services or government data. That is the data the government collects about citizens, and you can actually create an app and tap into any of the API that is available. Right now, it's only for a few things like KYC, education, financial verification, and employment records. But eventually, you can see the moment you start seeing the app, start using the app, the potential is visible where you can have a Arogya Setu connecting to it and provide health and medical records in one place. And you can have your insurance records in one place. You can have all your degrees also in one place. You can also have all sorts of financial transactions that you're recording. You can have it all in one place. So your tax system can also be linked to this. So anyway, our data is digital. Anyway, our data is available online to the government. This creates a platform where apps can be designed in order to tap into this data in a meaningful manner, without in a secure manner, and provide a meaningful interface for the user. So not all apps will be made by the government. For example, the NPCI made the app called Beam. So Beam is one of the UPI interfaces that users can use. But there are other apps also available like PhonePe, GPay, or Paytm UPI. Or there are other UPI like Amazon Pay. There's so many other UPI players available who can provide the same technology which is underlying this. So again, UPI is another example of using the underlying UPI ecosystem or the APIs which enable UPI to work to seamlessly transfer money from one bank to the other, which used to be a painstaking process in the past. People still do it. I don't know why, but people still enter the account number, the IFS code, and the details on the check. They will transfer a large SMS to some people, and then they will copy the information and hope they don't make a mistake. And again, there is a limitation to how much money you can send. In UPI, you just put somebody's UPI number or scan a QR code. You can pay them instantly, like you pay somebody cash from your wallet. So imagine with the India stack that they call, they've created a technology stack which takes help of all the cloud system to deploy this at scale. It's instantly available. It's rarely down. I have never encountered any of the UPI apps being down for more than a day. Maybe there was some problem in some banking system, or there is a banking holiday or something. I don't know, but the UPI always works. Nowadays, even the NEFT, RTGS things work all the time. So all these things are facilitated by the modern cloud computing technology, where APIs can run on the cloud. They can take advantage of all these high-speed infrastructure that we have. In fact, if you go through this website, it's actually quite educating how many different kinds of APIs are available, what are the policies that they have for apps to access this data. In fact, the Ministry of Electronics and Information Technology, METI, has a project called Meghraj. Again, fantastic name. It's a government cloud. Essentially, they use hyperscalers. They let hyperscalers bid for providing cloud computing services to the government, the Ministry of IT, and they essentially, on an arm's length basis, rent out this cloud services to any of the other government departments who would like to create services on top of them for citizens. So, for example, if you go to the Maharashtra government's website and log in, you actually have a lot of sophisticated documents you can generate and create for yourself. Any licenses or proof of property tax or whatever documents you need to create, they're already fed into the system because you've already made a physical payment in the real world. If you need to access any of these records, you can actually create a link to all these things. You can get the certificates online, and these are like valid documents you can show anywhere for any of your needs. So all these things are uh, possible now because of the Migraj initiative, where hyperscalers have provided, even, and hyperscalers not just the global ones, but even companies from India who are specialized in cloud computing service providers. So they have also enabled them. So if you read through the RHP, sorry, not the RFP, which is the request for proposal for all these services, you get to see the economics at which these companies are willing to work when they're working with the government. And government is big business, but it's not a big profit center. But what it does is it shows your capability to other people. That if something like this at this scale is operating at this capacity, you are able to use that as a use case and learn about what are the local requirements, what are the local regulations, and you can start pitching other customers, private customers, based with the help of that knowledge. So clearly, the opportunity set is for me, it's very obvious because I've been tracking it for a decade. But what I see is the opportunity set where Number one is complexity. Clearly, when we see that technology has evolved, it also has become a little bit complex. It is not complicated though; it is still easy to implement, but is something that will take a lot of effort and understanding of these various components. So, if you have somebody who understands a car tire very well, not necessarily the person will understand how the steering wheel works or the steering column works. The person may not understand materials or shock absorbers, but they will understand tires very well. So these are like hyper specialized services which create a lot of complexity, and for that you need very specialized manpower, very specialized talent to be hired as developers. So with complexity, you of course see an increase in hiring consultants, increasing in hiring IT service vendors, because they have the staff on call in order to implement all of these projects. Where we can see number of components also increasing. So, for instance, you we only felt that software companies can create APIs, but wait, I mean there are other traditional businesses who can also create APIs so that their data can be accessed by other people. Uh, for example, you have registrars, you have custodians, you have depository participants. They can all create APIs so that the apps which are using these can log into the data in a secure manner, authenticated manner, and for that you also need IT, you need a digital transformation mindset over there as well. You need to transform your existing physical business into a digital world where a digital app is going to use your data completely online, and there is no physical documentation or document trace anywhere. So the components are also increasing. The real world is getting closer, and at the bottom you can see O2O. It means offline to online. Imagine so many of our services or physical things that we do are actually becoming online services where you can actually interface with something online and avail of that. So shopping definitely has gone online, traveling has gone online, you can do payments online. So many of these offline services are becoming online now, and each of them require different components to be pieced together, and each of them require different talents and understanding where are these components available. uh, there's a need to modernize existing infrastructure, which we discussed earlier, that there's a legacy implementation of IT, and the legacy has to change over a period of time with digital transformation. So there is this modernization wave going on, which definitely creates a lot of opportunity for doing IT work. Then people want a reliability of service. So if somebody has been doing this for a while, if a company has been working with you for 30 years and has seen your scale evolve as a customer, they will know what are your requirements in terms of technology, and they will provide you a reliable interface to create your next step of IT investments. Plus they'll also help you with new technologies. So we haven't gone into the new technologies yet. No, there is this blockchain, and there is augmented reality, there's virtual reality, there is AI, there's autonomous vehicles, there's EVs. There's so many new technologies coming in which also have different implementations in the software world. So maybe some other FOF talk, but yeah, all these new technology implementations need also internal developing team, as well as somebody who will do the managed IT services work or the development operations work that is required for implementing technology. And lastly, and very important nowadays, is the security that is required for all these apps, where our data has become extremely important because everything is online. Our entire digital lives are available online. If there is a lapse in security somewhere, you actually have seen lawsuits going to hundreds of millions of dollars because data was not kept properly. Security has become a very important concern. In fact, even sophisticated security operators, like if you've seen Microsoft writing recently about their security concerns, it's actually quite interesting to see that such a sophisticated company can also face even the most sophisticated attack from either a nation state or whoever did it. But it's quite amazing to see that security becoming very important. But security can also be made into a component, and of course there are APIs available to implement that as well. So when you see all these things, when you see how the API economy functions, we clearly see that there is a huge opportunity for more kind of API economy to evolve. At the same time, IT services to evolve along with them. And lastly, I think the most important thing, you need to be very careful who you call a platform nowadays, because not every business will be in the business of platform. So one example which Jeff Lawson gives in the book is that, nowadays somebody says I'm a dental platform company, and they may be selling a toothbrush. So you be very careful who calls themselves a platform. You may not be a platform company, might be a product company, which is a commoditized product. So be very careful when you understand these companies, to go to the annual reports. When they keep using the word platform a lot, like your antenna should tune into what they're trying to say, and navigate whether it's really a platform or pretending to be a platform just to get the right evaluation. Another important thing a platform company has to do is to really know their customers, because previously you had a centralized IT expenditure where there is to be a chief information officer or the CEO who would determine that this is the IT budget, and within that it gets allocated across hardware, software, and services. But nowadays, you don't know who you're selling to. You might be selling to the internal IT team, specific things. You might be selling something to the marketing team, or selling something to the operations team. Each of them might be using some different kinds of software components. And there will be a vendor who's trying to integrate data from all these things to provide a system of record, to provide a dashboard of the entire truth of the organization, of what is happening where. So when you're selling a platform company selling these things, it's always useful to know as an analyst or an investor who their actual customer is, and that will give us an idea of how big the market opportunity can be, how big this total addressable market can be. Another very important thing with platform companies is to identify what their revenue recognition is. I mentioned earlier that some companies have gone to the subscription model way, where they get recurring annual revenues over a large user base, or some of them sell in traditional software product way, that they charge a license fee upfront and they do a AMC over a period of time, which is the annual maintenance cost over a period of time, and they charge to the customer in order to make sure that they maintain the API properly. So a lot of platform companies can have different business models, and those business models can have an impact on how the PNL is reflected, how the performance ratios are reflected. So it's very useful to see how they recognize their revenue. With modern platforms, we never know where the liability ends. There's obviously a fair usage of the service. So we have seen examples where platforms have banned certain users from their platform, or banned certain customers because it ended up using the platform in a criminal way, or a way which was not ethical or more moral. On moral ground, also people can throw people off. This is basically saving their backs. They're basically making sure that they don't get the liability from how their products are used, and platforms are used everywhere. So we don't. So, for example, if you've seen the story of the Silk Road, the website which used Bitcoin in order to sell illicit stuff like drugs and weapons and everything. So Bitcoin got a bad name because it was used in this very shady manner. But the point is, the liability of end use should not be on the platform; it should be on the users, which is how the fair usage policies are designed. But it's always interesting to read the fine print and see what is happening, how regulators are interpreting it, how law is interpreting it, which is generally all these things get discussed in the public domain. So you should pay attention to these information as well. And speaking of regulators, it's these regulations are now becoming an innovative industry, because you're seeing digital technology implemented in our day-to-day lives to such an extent. It has gone to such a deep extent that we are using technology nowadays. And regulators have realized that they are far behind the curve in order to manage how we interact with them, and they should not damage the individual's rights of privacy or freedom or whatever rights are called inalienable rights. So regulations are now tightening their screws across all of these platforms, and it will be interesting to see what sort of regulations. For example, in India, data localization regulations have really affected cloud computing companies, where they now have to set up servers in India if they want to sell to Indian enterprises or Indian government, which is a fair requirement, I think. But it's also interesting to see how it affects their business model, their investment plans. Do we have the infrastructure here to provide that kind of capability? So all these questions keep coming up when we start seeing regulations interfering with the way the business works. Also, in the API kind of businesses, like any product, if you do not maintain it and do not innovate it or upgrade it over a period of time, there's a natural decay in the way the product is using. There is some other product which comes up which is far better than yours, and you have a competitive product available now, which basically you could have avoided if you would have maintained the API and kept it up to date. So if you look at a API like Google Maps, it's probably the most ubiquitous maps implementation. So aren't there any companies which used to make maps for satellite navigation systems before? Of course there are. There are several large companies who are still around, who provide satellite navigation maps available to people. They have their own GPS investments that they have made, but we don't see them to be implemented in consumer technology. So it's quite interesting to see that if Google Maps was not perfected or updated over a period of time, you would also see Google Maps not being used by many of these apps. If it was not a good software anymore or good API anymore. Also, one of the big problems with IT services companies is the opacity of how they actually operate. So these are business to business deals. of course, very niche and specific deals. So not generalize any of the contracts. Sometimes margins are made somewhere else, but you show revenue somewhere else. So all these B2B operations are very, very difficult to identify. So be very vigilant when somebody claims to be a platform and they are actually selling to somebody else, but we don't know what the nature of the contract is going to be. There can also be rebates hidden inside, which we have to then figure out if there is any, and see that after netting everything off, what kind of money the company retains as cash flow. And lastly, there's been a way in which people were worried that because of this API first technology, there is going to be less work for IT services players. And is it like a threat to the overall IT business model? And clearly, when I saw the impact of API economy and the complexity it creates and need for other services, I think there are some areas, some traditional services, which will definitely be impacted as the industry also innovates itself and the needs also evolve. But IT services can definitely, if they stay on top of the game and they also update their knowledge and their capability of hiring the right kind of engineers and grow in this direction, I think these trends are going to be in their favor. So yeah, some areas they will lose, some areas they will win. So I will like to end with the quote that Jeff Lawson, the author of the book Ask Your Developer, uses. He says that what matters isn't how you use your servers, but rather how you serve your users. I think it's a very important thing that no matter what kind of cloud technology you're using, no matter how sophisticated the app is, it has to serve a business logic for the user in the end. It has to provide some useful service and it should make sure that it is taking care of all the needs of the end user. So with that, I think I will stop here because I've overshot my own time limit. Thank you so much, and I would love to take your questions now. I think we'll go with the questions that have been sent before. Uh, Ashish Bhai asked a question earlier that do you see the rising paychecks impacting the margin of IT companies? So clearly, rising paychecks is one thing. The most important that is happening is the talent that is there has also evolved. So most of these IT companies have spent a lot of time upgrading their skills in terms of having the right kind of people, right kind of engineers, which has evolved based on client requirement over a period of time. And I think if you are able to generate the margin that you were supposed to generate earlier by charging more, sometimes specialized services will cost you specialized revenue. So you can charge more for a specific amount of work in the contract, and some of the traditional work can be charged in a different way. And you can then balance your staff accordingly. Uh, it's a delicate balance. We from the outside can only generalize all these things, but really, if you have specialized needs, you are hiring specialized consultants. You need to pay them more. You can't be. There's also a competition in the labor market. So just like IT services companies compete for developers, there's a competition for developers even at the larger technology companies. So who wouldn't want to work for a larger technology company and make a bigger impact than work for a IT services vendor? So the competition developers is going to be there. There has to be some impact on the margin in the short run, but as and when the service is mature and the cash flow is mature, these things have tended to even out. So when you look at the longer term, like say 20-year margins of some of the IT companies, I'm amazed all the time that the margin cycle generally tends to be in the same band. It has not wavered dramatically. In the early growth years, it has actually wavered a lot, but over a period of time, it has stabilized in a narrow band. So the gross margins are actually quite healthy.
Okay, thanks, Ronak, and very nice presentation. Thank you.
Thank you, Ashish. There's a question from Rishabh Shirdalal. How do we value companies in the platform business? So, see, any business, I wouldn't go beyond traditional metrics. Sometimes our expectations of how much multiple to put on these metrics might vary. So, for example, somebody might say, "Oh, how can you pay 10 times sales for a business?" But if a 10 times sales business is growing at a much rapid pace without sacrificing the return on capital metrics over a long period of time, then I don't think 10 times sales has any meaning. In fact, all these metrics have to be independently evaluated. So the sustainability of the cash flow, the rate at which the sales is growing, the rate at which the cost heads are growing, the rate at which the company is becoming more and more dominant in its category. Some of these things you need to independently value and then see when you relatively compare with the peers in that industry, what sort of valuations based on the existing multiples like a cash flow multiple or a sales multiple or a EV to EBIT multiple, or even in many cases when there are no net profits, you can definitely not compare those. But earnings multiple in mature companies is also a possibility to look at. Some of these companies, for example, Amazon, it took us a long time to value the business properly because it always did not make sense in terms of all these traditional multiples. But the moment you see it from the lens of cash flow, the way the company operates, you can put a cash flow yield and then see compare it with other companies with generating in the same industry, and you realize that this company competes in so many industries. The cash flow yield, relative cash flow yield, may not be a right metric to look at. So you have to evolve your way of looking at it based on how each company works. But I think keen eye on the traditional metrics like cash flow generation. Can the company sustain? So do they need too much money from the outside investors again and again to reinfuse its capital base so that it can survive? Then clearly it's a difficult business to value, and you should let the venture capital guys value it. And also sometimes it helps to know what kind of an investor you are. So if you are into the venture and angel investing category, you would love to take such high risk bets where there is no profit, there is no positive cash flow for a long time. Yet you know that this particular company is going to scale itself and become a profitable entity. But if you are a more traditional investor, you're managing public money, it becomes you have to take a step back and just see that sustainability of these numbers are also very important. So Priyank has a question: software testing or software quality testing companies, if you can explain the future growth and relevance in the whole IT services sector. See, quality assurance is an important part of developing apps, and you can also there are also in fact there are technologies now available as APIs. So you can test in a specific parameter based on it using that API, and you can test it continuously in the backend. So the manual aspect of testing, which was required say 10, 12 years ago, clearly that has definitely changed. So many of these technologies are automated. So there is a whole uh, class of businesses called robotic process automation, and these automation processes can actually be run in the background when a software is tested in a UAT kind of an environment, and you can see how the software works in a stable condition, whether the browser is able to take if it's a cloud software, whether the browser is able to run with the proper resources or not. So you can actually do all these testings and quality assurance in an automated manner, and it can be provided as a package to the customer. In the end, if you're designing a software for somebody else, you can provide it as a package, or you can also call it like an API. So there are RPA companies now specialized like UiPath or Blue Prism. They're actually creating technology where you can use APIs for these things. So no, it's no longer the business we knew 10, 12 years back, where you needed significant manual intervention to do all this testing. In fact, many of the apps, if you see what sort of APIs they are using, many of them use an API for A/B testing, and it's a very interesting concept. So people are not aware of A/B testing. If there are say 100,000 users of an app, 50,000 users will see a different version, slightly different version of the app, and the remaining 50 will see the older version of the app. And based on the response of how they use the app, they will figure out if this is the newer is better or the older is better. So it's like testing a new flavor of Coke in a way, but using software. Vikas has a question where Indian IT companies are trading at 50% higher than the average 10-year valuations. I don't know if they will sustain, but I clearly see. So, I mean, when we look at the kind of opportunities that are available, there is a lot of work to do. But with work, you also need to figure out if niche needs are also met. So, yeah, it's always amazing to read a headline that company XYZ won this large contract. But again, it has to come with the same kind of margin expectations, the same kind of cost control that they had in the past. The company's directions have also changed in the past. So as technology has evolved, many companies have evolved along with it, and these have become large, complex enterprises. So they're no longer the chummy IT companies of the 90s. So yeah, it's I don't know if the valuation sustain or not, but there is work to do. So I think if you are at a scale and have the capability of doing it, you can only fail in execution now. So many companies we've seen, the ones who did not execute well in the past 10 years, they actually got beaten down in terms of valuation. Despite having the capability, if the execution was not there, until the execution was delivered, the market did not believe that the valuation should be given to them. So yeah, it's very obvious in some of the valuations. In hindsight, we know this that they did not perform. That's why the valuations languished. If we knew then we would pick the winners and we wouldn't be sitting here. Agam is asking a question: can data protection and security become a huge opportunity? It definitely is. It is also a crowded space. It is hyper competitive. Uh, a layperson can never know which technology is better than the other. So I would like to go with the Jeff Lawson's quote or phrase, like ask your developer. So if you have developer friends who are working in security or writing apps, ask them what security APIs they are using, which companies they think are more reliable than the other. What is interesting is in India, we don't have too many opportunities to invest in such companies, but many companies are listed in the US market. So if you want to really understand these businesses and how their business models work, it's fantastic. It's like a gold mine. You just go on SEC's website and download all the annual reports and just drown yourself in understanding how these different companies work, how the different components can be priced and valued. But it definitely, security is a definitely crowded space. It is so with every headline the valuations go up, and it's not funny anymore. It's we have missed a lot of these opportunities in the past, but security is difficult to understand for a layperson or a generalist analyst who is tracking the IT industry. Mukesh Bhai is asking which are potentially good API companies. So in India, like I said, there are so first of all the cloud computing technology, the base technology has always been an imported technology, so to speak. I mean, we are relying on these global companies or these open source kind of libraries which are available. So if you want to build a Swiggy in India, very unlikely you will have very specialized APIs designed by an Indian company in India, which is also in the listed space. But there are several companies. So in the previous presentation I made on financial data as a service, these kind of financial intermediaries are now venturing into creating their own APIs so that they can facilitate other participants who are using apps. So, for example, if a broker is upgrading their app and they want to provide additional functionality of data points as a fee to the customer who is using the app, they can tap into the exchanges APIs and they can show you additional information based on what the customer requires. Some of the financial intermediaries are quite ahead. So fintech itself is a very large space, and existing players which are already listed in the market, the intermediaries in who are fee-based intermediaries, are already there. So you might, if you are invested in them, you might already be unwittingly participating in the API economy to some extent. But pure play software companies are very few and far in between. Many of them are not listed yet, and some of them are relying on, like I said, imported technology so far. So what I find interesting is a lot of these implementations are happening on the public space as well. So there are many companies who are working with government contracts. IT companies, interestingly, also have their own API libraries because IT companies over a period of time have huge domain expertise in certain areas, and they realize that why are we reinventing the same process every time when we want to sell a service to the client? So what they're doing is they are bundling things into a package of APIs that if you want to implement so and so thing in your say domain, this package of APIs works very well. So you're selling an expertise of how to use the APIs, and sometimes they might create a layer on top of these APIs, which is their proprietary layer, their own API. So API which calls other APIs in a efficient manner. So even IT services companies are there who are creating their own APIs. But again, these contracts are not visible on the outside. You only get a general broad view, top-down view when you look at these companies. Yeah, I think if you're typing such a long question, just ask. I mean, I don't want to read the question here. Might as well, Priyank, just go ahead and ask the question.
Yeah, sure, Ronak. So the question is on the data centers. So can you see a third-party managed data centers as a big opportunity? And is there any Indian company listed or unlisted that can seize this opportunity?
So data centers are already an opportunity. It's quite a large market. So data centers in India, then listed companies in Tata's have a data center business. They also have a software platform business on top of that. You also have existing hyperscalers who are investing quite heavily in India. So they're not listed in India, but they are listed abroad if you want to tap into them. But there are a lot of other unlisted players as well who have been around for a long time. So I think Sifi is a data center provider who has been there. Then, if I'm not, Net Magic is another provider who has been there for a long time in the industry. So definitely there are many data center. It's a burgeoning opportunity. In fact, I wouldn't be surprised if there's a data center REIT in the future.
Thanks, Ronak. Thanks.
Hansal, why don't you go ahead?
Yeah, so I was just curious to know how this API fits into the one of the previous presentations you had done on platform businesses. I believe I think we were talking about exchanges and these the index. I forget what it was, but companies that were lending out indices for tracking or something. So how does this all tie in, if at all?
So a company who has data needs to create an interface to access the data in a secure and controlled manner. And for that, they will design a software process. Now, for a lack of better words, you can call it an API. And that API will essentially call a very specific part of data at a specific point in time. And because that API accesses the data which is stored, which requires some computing power, some database has to be there in the backend, they will have a cost of operating that particular API call, and then they will price it accordingly. They'll put a margin on top of that cost, and they will say, okay, now we will sell you for this so and so price. So, for example, if a person wants index data for the past 30 years, you within an app, so the API is already there. You just have to put in the parameters in the calendar and check how much time length of data you want. And the moment you hit submit, you will get the data to you instantaneously. And that is basically a service provided by some of these companies in the form of software-driven APIs. You don't need to now call somebody up or send an email, send me a CSV file of all this data, and then they will send it in their own sweet time. So you can create all these things. So even for example, RTAs, there are depository partners, CDSL, SDL kind of companies. These companies also are creating interfaces where other softwares can talk to their data in a controlled manner and a specific manner. So this is one of the opportunities for in the fintech world where, for example, if you so right, we have very restricting regulations right now because we don't allow open access to financial information. But there are some services in developed world where actually banks are allowing some of the API to be open, and a third party app can tap into very specific information about a customer. The same customer is using both these third party app and is a customer of the bank. So they get a benefit from the banking information. At the same time, they get to use a different front end. So, for example, expense tracking tools where the credit card company will give you a detailed statement and it will be linked to the expense tracker, which will tell you analytics on how you spend. I don't know why banks don't do it, but third-party apps are available who do that in some developed countries. In fact, there's an example in the book of a bank from Netherlands called BUNQ. So it's a fully digital bank. The regulations are actually loosened for certain kinds of banks to operate, and they don't have a physical branch. The entire bank works on a mobile app. It's not unlike a digibank app, but it is actually a little innovative. It has basic banking services, plus on top of that, they have a front end of different services, which generally younger people prefer to use in terms of how we use mobile phone. So we right now have the fanciest ecosystem of payments and banking in India. We may not find it to be very attractive, but yeah, in many of the developed countries where banks are old and not so sophisticated, there we have seen some of these new upstart companies coming up, and even they give an example of a traditional bank called ING, who actually revamped their entire bank to replicate the experience of what Bunk did. So a 150-year-old company can do the same thing that a 5-year-old company can do in terms of software because the APIs are available in the back end to work. So in fintech, I think it is the use cases are actually quite prevalent. You can see very unique use cases in fintech. The other areas, it's catching up slowly.
Great, thank you.
Kiyur, you have a question?
Yeah, as a industry, as a whole industry, what kind of threat do you see, or are there none?
So one threat is internal, where the company itself does not manage its API product portfolio in a better manner, and then there is a natural decay. Somebody else comes in and takes over that market because you are not able to service the customers in a meaningful manner. And secondly, there's always competition, right? So Twilio, for example, has several other competitors competing against them. in the same category. So they also have equally competent APIs for contact center operations and platform of services that they're providing. So why should a customer go to Twilio versus somebody else? So yeah, writing a book also gives you some marketing cachet that, yeah, this person becomes more visible, his company becomes more visible. But the point is, you will always have competition in API, some of the APIs. So just like in any other business, where some moat can only exist if you are doing something very well at scale for a long period of time, and other people will just need to put so much capital in there to crack that market. Over there, you might have some kind of a competitive advantage. But it's like any other industry; it's going to be cutthroat in many areas, and because of the speed at which things can develop, you really need to have 2 3 rear view mirrors to see who is coming from behind you, because it's going to be really tough. Many companies will face a decay far sooner than we notice. So yeah, sometimes I see the valuations, my eyes water. But yeah, we have to be very vigilant as analysts and investors to track these changes.
Thank you.
Nihar?
Yeah, thank you, Ronak, for your presentation. Okay, my question is, now as you just said in one of your slides that most software these days is stitching, right? So what happens to those legacy guys who are already there in your old IT services companies and doing systems integration or SAP implementation kind of jobs? Are they going to be unproductive and still be earning salaries?
From a human resource point of view, this is not a binary thing. I mean, this change is happening over a period of time. There is always a opportunity for retraining your staff. In fact, the more people you have trained on the newer technologies, the more you can show that a capability exists to deliver or execute a contract. So there is an intrinsic incentive for retraining your staff for any organization. Also, some of the old work or legacy work that people talk about, actually the work exists. It's not like the work has gone away. The work has become more sophisticated and easy to manage. So what required 100 people can be done by 10 people, or by a software or automated piece of software. So all these things can be done and can be achieved. So you need people to also be trained to use this automation software better. You need people to implement the different combinations of components also. Sort of times people might, like I said, they have these bundle of APIs available for certain use case. There might be a specialized use case somewhere where this bundle may not work, but if the bundle is tweaked in some way, you can use it. So then if you can sell it as part of a larger contract where there is a managed services piece attached to the digital transformation piece, then you will require the entire stack of people. You cannot just say that the legacy work will not be done. But clearly, the legacy work has reduced, so the growth will not be there in those areas, because some of the legacy work that was there, infrastructure management. Now, if stuff is on the cloud, there is nothing to manage. The cloud computing provider is managing the infrastructure for you. So that kind of a person probably has to be retrained, or he has to work for a cloud computing provider now, because his skills were more relevant in a setting of that type where infrastructure needs to be managed. So uh, people get displaced, job gets displaced, and retraining is an intrinsic incentive. I don't think companies would want to lose somebody who has been trained over a period of time in their own organization, to just let them go without being given a chance to retrain themselves. So we have seen a lot of reskilling happening. Now people can debate whether this reskilling is really a good quality reskilling, or a reskilling which is just for creating a label of employees that you have so many people who are trained on modern technologies. We don't know that, but clearly, since there is work happening and people are executing contracts of more complexity and large scale, there is some iota of truth to that, that reskilling is definitely happening at a large scale. I think we have actually crossed. Thanks, Nia, for the question. Thanks, everyone, for the questions. I think we will end here because it's already 8 o'clock. I wouldn't want to get in between people's dinners. Thanks so much. If you have questions, you know where we are. So just shoot an email to us, and probably we can discuss this when we personally meet in one of the FOFs.
Thank you. Thank you, Raunak.
Thank you.
Thank you very much. Yeah, bye.
Whenever things got rough, I always remember what my father used to say.
Running a business does test a man, my son. There are ups and downs, glorious highs, and sometimes a low that leaves you feeling defeated.
The character of a man and the character of a business are not very different, are they?
Yes. But when the chips are down, we must stand up, dust ourselves off, and motor on.
Volatility. It's a funny thing. It makes you question yourself and wonder if you've made all the right decisions.
Sure, you can question some of your decisions, but stay steadfast on your goals.
Dad always said, there are no shortcuts and no quick profits.
There are no free lunches, are there? There is only one
Right way.
At PPFAS, we think like Rahul and his father. That volatility is a fact of running a business. And buying equity shares is like owning a part of that business. We use value investing principles to manage your money. This means we invest in the right businesses at reasonable prices and for a longer term.
PPFAS Mutual Fund. There's only one right way. Mutual fund investments are subject to market risks. Read all scheme-related documents carefully.
Mutual fund investments are subject to market risks. Read all scheme-related documents carefully.